we are in the same situation because Professor Bolchini can't participate today, but luckily we have the head of the Geoinformatics engineering course, Professor Ludovico Biagi, who will welcome all of us. He's also part of the project, and so he will welcome us. And a very quick comment. With respect to CADEO, we have still the problem related to Fenica University, because unfortunately by now the procedure is not finished. I have to leave at certain point because I have to discuss with Emanuela Zonca in order to better understand what we can do, because we were supposed to sign everything by the 9th of November, but the procedure with Fenica has stopped, and I already wrote to the officer twice, as a matter of fact, but I didn't have a reply. So we have to check. We have to check what to do, because everything is fine with all the universities, but the Fenica one. Something was stopped, and by now we don't understand what, because in principle, everything seems to be done in a correct way, but they are not in condition of appointing the leader. So we have to check. Anyway, okay. Now it's time to start with this project. And so first, in the beginning, I want to give the word to Professor Biagi for his kind introduction.
Good morning, good afternoon, everyone. Unfortunately, yesterday I had surveying and it was a rainy day, a rainy winter day in Milano, so my voice is very low. And yes, I'm very proud of this project, of which I am a small part. But today I'm just giving you the welcome as the chair of Geoinformatics Engineering at Politecnico di Milano. Maria Brovelli is an estimated professor in geoinformatics, and therefore welcome to everyone, and I leave the floor to the project discussion.
Okay, so thank you so much. So the workshop today is organized in this way. So first of all, welcome to everyone. And I have also to say that I'm very proud of this project, because we are doing a lot of things, a lot of research. We are learning so much. So it was a good occasion, and I'm very happy of this collaboration with the Vietnamese teams, with you, because I see how your expertise can be mixed with our expertise to do the best we can do, as a matter of fact. So thank you so much for all of you and your commitment, how serious and committed is your activity, and so on. So thank you for that. But then I want to thank also the other chair of this project, so the co-chair of this project together with me on the Vietnamese side, Quang, my friend Quang, also for the commitment, both from the scientific point of view, but also the friendly way he is managing this project, and how friendly they are hosting now, Basil, and before me. So thank you so much. I believe that this is the good way of doing this kind of projects, that are projects between countries, because it's really important to do research, and we are doing in the best way, I believe. Meanwhile, it's really important to let the researchers knowing each other. And I believe that the next Erasmus project will be again a new occasion also for spreading this knowledge also to other universities. So I'm very excited, looking forward to working with more teams in Vietnam under the guidance of the people that are here, who are here today, Quang, but also Professor Dean and the Professor Andy, and all the people here that are uh, so good researchers and scientists. Okay. And Quang, I don't know if you want to say something or we can go ahead and you will speak later.
Yeah, I think I can speak later. So, because Dr. D, he's always busy, as you know. He want to move his presentation on the first presenter because he's had the meeting with embassy of with someone in Brussels. Yeah, something like that.
Okay,
You
okay.
can take
Fantastic. We will do in this way. We will do in this way. I don't, if it is fine with the other people, if Professor Van Han is confirming that is fine and you, Quang, are fine, we can do in this way. Are you fine? Do you agree, Quang and Van Han, with this
yes, yes,
change?
yes. Yeah.
Okay, perfect. So at this point, we start our meeting with the first presentation, which is a presentation given by Kwok Di Nguyen, and with a work that was done also by some colleagues of him. He will better explain. And the title is Combining SAR Imagery for Landslide Detection and AHP Method to Build a Landslide Susceptibility Map for Van Yen District. Okay, and Cook Tandong debris flow early warning. Oh, no, sorry. Oh, Cook Tandong, I don't know if it is correct, the pronunciation, debris flow early warning system in Vietnam.
Yeah. Could you please accept me to share the screen?
It's not me. I don't know, probably it's Quang or Basil.
Me. Can you try now?
Okay,
Okay.
I can do it now. Can you see my screen now?
Yes, yes.
Yes, so we
Okay.
can.
Okay, thank you very much, Professor Maria, for reorganizing the sequence of the presentation. The presentation I prepared today a little bit different from the title that presents in the program. So it's the application of IoT and big data toward the debris flow early warning system in Vietnam. So it's quite some very new works that we have been doing in the last 2 years, focusing on the early warning system for debris flow in the mountainous area of Vietnam. And this works has been conducted by our group in Vietnam Institute of Geoscience and Mineral Resources at the Department of Economic Geology and Geomatics by Dr. Nguyễn Thành Long and also Dr. Nguyễn Minh Hiển. So I go from the some very short overview of landslide and debris flow in Vietnam, the damage and the loss. And the second one is focusing on the debris flow early warning system and some recommendation. So this slide is already, some of you already see it. It's from NASA to indicate the hotspot of landslide around the world. So Vietnam is just in the middle of the area that is whoop, sorry, that is frequently of the landslide with the damage come from around 10 to 100 people, and most of the events cause the loss of 1 to 10 people at once. In the last 50 years, according to the inventory data, we have nearly 450 big landslide events. That is about 7 events a year. But in the last 15 years, from 2000 and 2015, the frequencies is much higher. So it's 15 to 16 events a year. And in the 15 years, so the loss of people is 780 people, and 430 people injured, and nearly 10,000 houses destroyed and 100,000 houses damaged. So it's the cost of the damage is huge compared to the other natural disaster. So for the landslide research, we have been doing from a local scale, at the scale of 1 to 10,000 to 1 to 100,000 scale for local landslide mapping, and also for modeling and early warning system. For regional scale, we also work with other countries like Thailand, Laos, Cambodia, Myanmar, to work on the landslide mapping and modeling at 1 to millions scale. At the global scale, so we cooperate with the team of NASA, led by Dr. Dalia Kisbal, for the global rainfall trigger landslide hazard characterization. So it's we working with them for contributing the data for constraint of the model. At our group, so we focusing on both using big data and also the IoT for landslide early warning system. For the big data, mostly we use the data from satellite image with different free source of satellite data, and also using the UAV for collecting the data and the sensor at the site. And all the data, we use different methodology for application. For example, mostly for disaster management. In this case, landslide zonation mapping, and also landslide early warning system and debris flow early warning system. So here's the aim of the out project, and our long-term project is establish a smart resilient platform where the sensor at the site, we collect the data and we transmit through the transmission layer and going into the processing layer, and at the end use interface, we deliver, we go to the deliverable layer. So it's a long way to go, but I think that this smart resilient platform is very important for the future disaster risk reduction strategy of Vietnam. For the big data that come from the from the satellite data, at the moment we can access to different sources of data from NASA, from JAXA, from ESA, European space agencies, and all of this data we can collect either to our database, or we can process through the Google Earth engines. And at the moment we use a Google Earth engine as the mean for processing data. So here's the landslide susceptibility map at the global scale. And here's we use global rainfall data for predicting or forecasting of the landslide uh, 48 hour or 72 hour in advance. So for the debris flow early warning system in Vietnam, we start from the review of the paper that already published, and we know that at the regional scale we have different system that has been in operation. You see that operational in the square here, and most of the national scale system is also in very early system of designing or pre-operational, and very few system are already operational stage. To this point we choose the system of Taiwan for national scale to be the model to study and to transfer the technology to Vietnam. For that one, we in collaboration with Soil Conservation Bureau of Taiwan, we study the site, and also we support from them for the equipment to install in the area. So in this figure, we see that the DM of the Bản Hoang catchment, where the debris flow happened in 2013, that caused the loss of 14 life, and also the damage of the more than 20 houses in the end of the catchment, in the end of the river. So here's we are working on the field. We are going to the field 2 times, and we detail surveying of the catchment. We see that the old landslide in the top that caused the landslide that caused the debris flow in 2013, and we also found the active landslide in the middle stream, and we also identify the protected area that need to be protected by the early warning system. So if something happened in the either in the upstream or midstream, so the time for evacuating the people in downstream is just less than 10 minutes. So that means the system must be quickly respond to the any event that may occur in the upper part. So we see here the rocks fall and landslide in the past, and we see here the active landslide in the other sides of the river. From that, we use different IoT sensors to collect the data. For example, we have the water levels sensor camera, we have the rainfall, we have the geofall here. All the equipment we collect the data into the server at the site. It's a very durable computer, and also case and housing here can be can put in the outside weather. So here's a layout of the system that we have been working on. So you see that from the image, UAV image here, we identified where the stream, where the active landslide, and we install the sensor that can monitor the active landslide, monitor the seismic activity by geofall, and monitor the water level by water level sensor. And we also have the Y sensor to identify the big boats running in the river if there is any of them. So on the this one, we carefully choose the area that can be installed, and all the data are stored in the house that's the other side, and the data transmit to our server in Hanoi for further processing. So here we see the equipment that already installed at the site, the geophone in the middle stream, and the camera that collect the movement in the active landslide if something happen. And here's the Y sensors, the camera, and the water level instrument, and the rain gauge at the downstream. So the data center here, we process the data in the, we collect the data here in the data center. And here's a data center at the close look. And all the data are, we can monitor 24 hours. For example, water level, Y sensors, the rainfall, the geofall, and also other parameter of weather and hydrological data. So after the analysis and processing, we set the threshold for warning hazards at 4 level: safety, low susceptibility, high susceptibility, and certain to occur. And whenever we have high susceptibility, so we inform to the local authority to give the early warning. And whenever the certain to occur event, so we also put the alarm, set off the alarm to evacuate the local people. So here's the just for example that we set for the high risk level for the debris flow disaster, with a different threshold of rainfall, of camera, of water level, and also Y sensors. With the same concept we use in Bản Khoang. We installed the second one in Mù Cang Chải, the site that our project also visit and has some activity there. Only thing that is different is we produce some sensor and produce the software by ourselves for monitoring of the landslide in the Mù Cang Chải area. So that means the cost of the equipment here is much lower than the cost of the first early warning system in Sapa. And the third one we already installed also in Sapa, nearby the site for the first early warning system. And this one is for multi-hazard early warning system, not only for landslide but also for debris flow and flash flood. So we setting the criteria for selecting the type and quantity of sensor for each type of hazards. For example, here in the upper part, here in the red part, we can see that the sensors that for landslide that is installed in each of the landslide to monitor each of landslide. And in the downstream and middle stream here, we install a lot of sensor in the middle part. For example, the inclinometer, the water level, Y sensors, and all of these are also collect and put it into the database for further analysis. Another program, we are in collaboration with Japanese partner to propose the project preventing an early warning system for landslide and debris flow in northern mountainous area of Vietnam. In this project, I think that it's already ratified by Japanese government, but not by Vietnamese government. So in this project, they are going to install a lot of sabo dam to prevent the reflow in the stream. And I think that for sabo dam, it costs a lot of money. And for Vietnam, the budget for sabo dam, I think that in many cases is not feasible. So the other system that also proposed by our partner, the Okuyama company, they also set up several systems in Vietnam for landslide monitoring. So this is just for landslide, but not for the reflow. So they install a lot of sensor in other side, for example, extensometer to see how fast the slide movement in comparison to the water, the rainfall, and also the soil water content. So that is only three parameters that they collect in the field, and this is the system that already installed in many places in Japan. And also we also work with other company to test different instruments for the early warning system for landslide. And one new equipment that can be used for landslide early warning system is the ground-based synthetic aperture radar. This equipment can scan more than more than 500 meters, for example, in the stable area, and scan to the landslide area, and we can monitor the landslide quite in the very fine temporal resolution. So there are some conclusion that we already see it sometime and some place that in my presentation. So I think that the landslide and the reflow occur more often and cause huge loss in Vietnam, especially in mountainous area. During the due to the climate change, the extreme events are more and more often, and they will cause more landslide and debris flow in the heavy rainfall event. And on the existing early warning system that are in the development stage, and it requires more time to develop and to evaluate, and also it's necessary for the nationwide scale. And at the moment we use Taiwanese technology and Japanese technology, and I hope that through our project we can learn from Italian experience, and we can transfer the technology from Italian partner. And I think that the transfer technology to Vietnamese partner, we also need to transfer the solution and also the technology to produce the sensor, so to reduce cost of installing and maintaining the system. So thank you very much for listening. It's the end of my presentation.
Thank you. Thank you a lot for your very clear and informative presentation. Congratulations for the research. And yeah, I believe it's a pity that you are not here in the end because there will be a discussion later on. But I believe that the colleagues, the Italian colleagues here, who are more closer to, or not more closer, but closer to that part, I mean, the geologist, first of all, I believe that they can contact you in the next days, in the next period, for if they want to have pieces of information. For sure, it's fine if you can share all the papers you are also writing with the other teams, the Japanese team and so on, in such a way to update us also with respect to this part of the research. So thank you so much.
Thank you.
And then we go now to the second presentation. Before going to the second presentation, I want to say that on the Italian side, we are here also some master students, because there are some students who are starting the thesis together with us on specific topics, but I believe that then Basil then will present something about that. Okay, so second presentation is a presentation given by Kwang, and it is related to web-based Vanyan and Mukhan Chan district landside information. So Kwang, the floor is yours, or Professor Chuang Kwan Suang Wang Kwang. The floor is yours.
Thank you, Maria, for introducing me to say. So, okay, let me share my screen. Okay. Where's my screen? Okay. Can you see? Okay. Yes. Okay.
Yes, we can see well.
I would like to present my topic today is web-based is for landslide information is example into two provinces, Vanyan and Mukang. Is actually it's like a summary how we build this kind of system. So the first of all is okay. Oh, sorry. Okay, the outline today. So I would present how what is the system diagram, and the most important thing is necessity map for the to know which area is most sensitive and most dangerous for people around. And because problem of data, so we need to update everything. So I will present the third point with the updating landslide inventory. And also based on that, we have an idea to improve and to monitoring the landslide. So I will present a bit about the fourth point is landslide detection. And we would create like a warning system for just for landslide in our project. Is we have a two trigger point for trigger landslide in two provinces is rainfall and earthquake, but earthquake is less in Vietnam, so we more concentrate on the rainfall data. So there is, as the last one is overall our system. So the first is that maybe someone has already seen many times. So this is like what we can share here. We have most of familiar tools like GRASS, GeoServer, and Axis, etc. This is like a core of the core of our system to scan the data around what we can have as much as possible. So we cannot, now we name it like Geo's information. So, for example, we have here, we can collect from data from mobile app, there's science citizens. So we also have different resolution of satellite image or UAV. Yes, and from all the open data, and we can using the most used technology nowadays, machine learning, to create the base map for our system, and from the strict parameter, and then we consider about empirical and non-empirical model to know when landslide happen during the rainy season, or suddenly rainings, maybe sometimes based climate change problem issues. And also we have some bit amount to study deeper by using geological survey, and I will present you later. So for forecasting data, we use several different type of open source data from a lot of sources, but we focus in GPM because we use most in Vietnam. So next slide is a system diagram how we build success TBT map. So nowadays, as many papers showing us, is many different methods to build up the landslide successivity map. So we in Vietnam, there is someone still believe on the statistic and expert models like AHP or frequency radio. So we also need to build them up to compare with the just say like a modern model, new model. It's not new, but we should we can say that it's new model in some because now we have some several system to scan all the data around Vietnam, but I think they use like statistic model. So we need to explain the department of, for instance, Monterey Ministry of Environment and Natural Resources, that our machine learning model may be always better than the previous model like frequent radio or AHP. So that's why we use as much as we can in our study to build the landslide sensitivity map. And here is all the information we can have. We have a lot of information. I think now we have more than that. We have weathering technique map. We have lithology map also. But I will add it later because we have, and also we have a new land use land cover map. Is from official map, not from image, not from our model. So here you can see we have also like slope, we have plane curvature, we have profile curvature, we have a road buffer around, we have river, we have NDVI extra, as you can see here. We have maybe more than that now. And for landslide sensitivity map, we use or here we use frequent radio. Dr. Dong will present you later. We also have AHP. We have random forest when we work with Maria and Vasil. So thank you for that. So we can get something like this in the middle. So we have also support for my team. They just build it up by Google Engine with the help of Vasil. And we have also logistic regression result is also from my team. Okay, so the comparison with comparing within all the methods, As you can see here, random forest STEAM is the best method which we compare with all the methods together. Random forest is about 0.913 something, yeah. And the second is logistic regression. Okay, now I will show you the web-based system beyond the random forest landslide successivity map. Yeah, these are because random forest is better, the best model for viewing now. So in the future, maybe we find something better. Now we try to do that, but at the time, random forest is the best choice. You can see two landslide susceptibility map for the two provinces as in the slide showing you. Okay, and that is data we achieve, we get from the best place in Vietnam to collect data for related to geology, for landslide, for the bit flow. That is a ministry institute of Dr. Ding, who is taking took the first talk. Is a Institute of Geology and Mineral Resources. So for updating data, because some of data is very old, is in 2014, and they up to date in 2018. So it's not so good data. So we have a little bit amount to use a UAV to fly in each province about 40 kilometers long. And you can see here, we can see the UAV imageries, photo. So the map survey team tried to find out the landslide location based on UAV, but because we have fly only one time, so we just use very normal technologies like landslide interpretation. When we have time, maybe we can consider for next fly, and is we can use polymer technology to find more land movement around two provinces. As you can see some result here, we can find this, and normally we go again and check. Yeah, these are Puranian districts, we go 40 kilometers long. And for in by province, we go a bit separate, look longer. And it's also the same result, flight on I think in October this year. So it's a good time when we can fly again to find something else more. As the team from Map Survey is using landslide like a normal interpretation to mark more landslide point is possible landslide, but we check it, and it's about I can say 80% of them is real landslide. But this is only on the survey. What is about underground? So Professor Van Anh will present what technology apply for that. Okay, and very strong tool we have in hand now is also supporting from Politico Milano. I think it come from also the master student work maybe some years ago. Is a very good tool. So we already apply, and we been to we went to field 2 times. One is with Maya, and then we bring two the app with the 2 different iOS Android phone to collect the data, and 2 days ago with Vasu, we go with different direction, different provinces. Yes, and we can collect some data if we can see it's a landslide or spring appear on the ground, or some signal that we can think it can be landslide. So it's a very good tool now. Now it can easy to get the data, and the data sent directly to a Polymese server, or even we can send directly to Vietnamese server. It's a my server, and we can up to date the data, whatever we want. And in the future is a very good if we can achieve it, we can send it, or the like a citizen or local people can apply our product to contribute the data for our study or for our system in the future. So I hope that work. And for landslide detection, we use both method. One is from like a survey that like image interpretation, just like on this survey, and one is using the SAR image processing. Is can see something slow movement without any signal on the surface. So Professor Van Anh will present deep about that later. So and also we also try to using different images for study lens use and cover chains, and we hope that we can find something on the surface also. And the first method we use we find some threshold between three different indexes. We have NDVI index, normalized difference vegetation index. We use normalized different water index and barren soil index. So from that we actually we follow the one of the place they put like a network for sharing algorithm for predict landslide point. So we follow that groove, and we also try with that algorithm. So this is the result. Is you can see we can adjust something from the ground using Sentinel data, but is not so always. For instance, it's mixing river and urban area with landslide. We can see in right side with ovans, red ovans. You can see here. So it can help us a bit to save time when you want to do landslide interpretation directly from image, but it's not give you this much decision about which area has landslide. Okay, we go the better algorithm for that. We use deep learning unit, but the problem is that the training set data. We also follow the network before. As I said, that is a landslide for sense, but they have a lot of training data. But for Van Yen district, we don't have Mugan Chai district, we don't have the training data yet. So our team already done something. We try to find from Google, from the real data what we have from the fieldwork, we find the place and the shape of landslide, and we also use this type of data for enrich the training data of landslide for sense. Okay, but this we not done it yet because for following the Git code, okay, is perfect. We can work with the data, but for our landslide data is not work much because our landslide is I think is smaller, much smaller compared with their testing data. So luckily we have UAV imagery, but UAV is like quite very good resolution compared with Sentinel. So that is also problem because because we using this is the set of convolution network. So using convolutional network, you need to cut a piece of image to reduce the size of image, and then you the reverse again. So the because the resolution is not equal with the training set, so that's why it cut off also the shape of Landslide. That is one problem. Now we try to solve it. Yeah. Now this is not a success yet, but we will move. We will go continue in the future. And for landslide detection by using SAR, Professor Van Anh will present deep about it later. I think she will explain more better than me, so I can keep it back for her. Okay, this is some result from SAR image processing result. Okay, and the other main part related to hydrology section is rainfall. So we have budgets to use real-time data, near real-time data. Every 10 minutes we can request one request data directly from the install station. We buy 6 stations in each province, 3 stations. So and we also have some decision from Ministry of Environments and Natural Resources is the right address for to make the decision for all the Vietnam. So we have something like on the table. You can see if very heavy rainfall is about 25 millimeter. You can say it's very heavy rainfall or heavy rainfall. And we use historical data for losses. Sorry, and it's like that. So we use some web API to query the data, and also we design it to make it easy to get data later, for example, by terms, by location, by statistic, or like follow the function. What is name, how is called is empirical function to know where and when and how long is much rainfall very sensitive for landslide. Okay, we design at like a web API, and also Dr. Ha from Institute of Geoscience. He has a long time to study about landslide around Vietnam, and he has very good data for losses. Not so good if you compare with the foreign country, but in Vietnam, if this data is also good because it's difficult to find. Okay, and we make some relationship trends between the losses and rainfall. So we we know the function, the formula between the rain and landslide for our study area. Okay, compare between the decision of our Ministry of Environment with real data there. When in May, we can see is very big rainfall, is like heavy and very heavy rainfall, and we visit the field is a lot of landslide happen, but not too much, but it's like the small debris flow, and you need to clean up your road, otherwise the car will be blocked, etc. It's a long road, is a lot, yes. And for deeper understand about study area, and also thinking much and understand better which factor and the study for the trigger about landslide and sliding around area. We also have a geological survey. I just got a new result from the geological team about electrical resistivity and the data from the laboratory lab of geological from drop. For instance, shear resistance or slide resistances, coefficient. So the geology team have many work to do after we have this kind of data, and we maybe need something more detail on what we have before. And for system, so as you can see here, and we also put some line here. If the rainfall stricter or higher than some threshold, we will have in this in red color here. And you can see above is a landscape map, and below is a land cover by using random forest for Sentinel-2 data. So I saw some example here. Okay, here is like is our system. You can see the like a short bulletin, not bulletin, but information about it. And this is not completed yet, but we can see something like also population. As we learned from the GIS code, the polymy is very good, very good knowledge for us now. For example, we can see, oh, where is that? This is not like a final job, but it's like the test of us. I think in the maybe 3 months we will complete it. For instance, population here, you can see some population also along this. Okay, we can see the landslide sensitivity map based on random forest, etc. Yeah. Okay. I go back to this side. Okay, thank you. So I move the conclusion to the discussion section. Thank you for listening.
Thank you. Thank you, Professor Trong, for the very nice presentation, very clear, and we are happy to see how our collaboration is getting better and better. Also, with this part of the WebGIS, we are working together, as a matter of fact, and everyone can see how the result, if teams are working together, is improved. So we are really doing well. And now we have the last presentation. I'm very happy to have the presentation of Professor Van Han, who is an excellent researcher in Vietnam, and I'm very happy also to have a lady representing the project as well on the Vietnamese side. And Professor Van An will present the comparison analytical hierarchy process and the frequency radio method in assessment of landslide susceptibility, a case study in Van Yen district, Yen Bai province. Okay, the floor is yours, and then after this presentation, I will move, as I told you, to the meeting with the other project, but then I will back again. Thank you.
Yeah. Hello, Maria. Hello, everyone from Italy side, and hello from Vietnamese side. So this is the name a little bit different because maybe confused between me and Dong. So the title of the presentation is about the combination of site imageries for landslide detection and frequency ratio method. It's not to build landslide susceptibility map for Van Yen district in Bai province. The content I will talk about 2 parts. The first is to detect the landslide using time series of site data, and we focus on the Sentinel-1 satellite images. And after that, we use the result from Sentinel-1 data detected from the certain one data, and it become to the training data for the method, the model frequency ratio to detecting the landslide susceptibility map. The first one is I want to talk about the radar images for monitoring these landslide. Firstly, I'd like to say a little bit about the radar images. As you know, with the radar, it's had the two part in one single look complex images. So in one single look complex images is divided in two parts. You can see in here is one part is called intensity and the other is phase. So the intensity images is can visualize, you can see is black and white images as usual as like optical images. But in case of phase, like an angle, so a little bit different. The idea that if we want to have to detect the change of the elevation of the surface, we have to at least two images. So two images will create the change of the phase. So they call it interferogram. So the interferogram, if we have two images, two acquisition of the same size, we will have to make the multiplication between two complex images and create the one interferogram. So the interferogram is very sensitive with the surface elevation and also with the change of the elevation. So that way they use two images or at least three images to create the typical method called GEOINSA. So or you can see the equation in here, the change of interferometry. So in this interferogram, you can extract the change from phase displacement. And in this equation, also including the phase of topography and atmosphere of the first and the second image that we call it the master and slave, and also the orbit, phase orbit. So the idea that if we want to extract the change, that means the phase displacement from here, we have to remove the phase of topography and atmosphere also. But if the two acquisition time is have long gap, that means the atmosphere change much. So the phase between the atmosphere of slave and master maybe is can have the high error in this case. So that's why if we use only two or three images, it will exist much errors from the atmosphere. So that's why they have to use a time series of images. So with the time series of images, we use the orbit is as short as possible. That means we have to select many images to select the point that have the high backscatter of the point. So the high backscatter will have the stable of the scattering, and we can select that one to detect the change if there's point they have something change in this this point. So here is the idea of persistent scatter. If we have many backscatter point and we select this point for all the images for time series. So in this case, we usually have to select one master image and the other, we call this the slave images, and it will make many baseline between the master and the other slave images. So here an example of the graph of the time series images between master and many slave images. And remember about the selection of the images, slave image comparing with the master images. That means we have to select as short as possible with the these baselines, temporal baseline and spatial baseline also. So in the case of our areas, it also focus on Văn Yên district in Bai province, as Quang said more detail about that. So in this area have the typical that have many river and stream network in here, and usually landslide happen nearby the rivers and the stream at these high slope. So the data we selected Sentinel-1 data, ScanSAR. So the ScanSAR is one type of images divided in 3 sub-SWAT. And with each sub-SWAT, we have to separate. When we process with this kind of data. So in this case, select the descending orbit with VV polarization and 31 images from 2019 January to 2021 May. And the master images we selected is 2020 March 18. And with this kind of images, there's something a little bit difficult to see when you see the strike on the images. That means the birds is each sub-SWAT have 9 birds, and we have to disperse this to make the more reasonable for the images for processing. So the processing we use is 2 software. As the first one is Snap, is from ESA, Snap free software to create the pair of image between the master and slave images, and the other is MPS. It's also free software running on the base is MATLAB. So here's an example. With the Snap software, you can use the graph building and run it automatically. But we use the Python command, using Python command for running this in GPT of Snap, and export to MPS running on operating system. Here is the chart of position and the connection of Sentinel-1 images, 1A images. In this, you can see in here the requirement for the baseline usually is have as source as possible for that. So in here, when you see the master is not so bigger than 150 meters. So this is okay for the requirement for the graph of time series of images. So this is the result. As also you see the results that also Quang showed you before the landslide happened much in the area with high slope, and also is along the river and stream in my mouse in here in this area and this area also. So with this one, we select the landslide with minus results, and to make the training point for the model. So the model we select in here is frequency radial method. So this is the method is not so difficult. It's the simple method. It's using the number of pixels that have the landslide on the layer, the input layer. For example, if we have 10 layer like aspect or slope, we have to use these landslide point that from the results of the Sentinel-1 data. We overlay and to compute how many pixels belong to the this X class of X cluster of of slope images, for example. So we just select the landslide belong to the each classes, and then compute the total of number of pixels of each class in the whole areas, and the number of pixel, total of pixel containing in landslide also, and total number of pixel in the whole study area. And this is also like multi-criteria. We have to sum up all the frequencies ratio together with all the input layer that we computed in this. We can have the landslide susceptibility index LSI map after using that. But in this case, we use two model using for comparing. First one, we use the data from inventory map. So from inventory map that Quang showed you before, the inventory map selected maybe from 2014 and updated from 2018. And the second, we compare with the PS point that I have just computed before, and also had to reduce the point up to 300 point, and using 10 layer. 10 layer, for example, in here is aspect, slope, and surface curvatures, and plant curvatures, fault, and transportation buffer, TWI or rivers buffer, or land use, land cover, and the last one is lithology. And using all this one with two model. That means the first one using the training point from the inventory is 70% for the training point, and the testing point is also from field inventory is 30%, and the AOC, the error using a ROC, and the error is about 0.77. And you can see in here the susceptibility is high, very high, and high is red and yellow color. It's also along the rivers and near the road, and also the stream in this area. And using with the PS inside, also we select 70% of the point for the training, and the testing point. In this case, we use the field inventory. It's not use PS inside, and with 30% of field inventory, we compute the ROC, and the error in this case a little bit higher, 0.779. I don't know why, but you can see it here with also with visualization, you can see the very high and high, also nearly the same with before, along the rivers also, and along this stream, that a little bit, the very high, a little bit higher than the inventory data. So after all, I had a little conclusion. I think with the radar satellite images, PSINSAR had better understand and more progress of landslide. In addition, based on the time series, Sentinel-1 data's landslide velocity can be generally calculated at certain time, even for small deformation. And I think if in case we don't have the in this check, I think if we don't have the inventory map, or we cannot go to the field, maybe we can select the point from PSINSAR for running the model. So the accuracy for the second model, because with using the second model, PSINSAR, from 70% for training and using 30% of inventory point for testing and checking the accuracy, I think a little bit better when we use all the inventory points. I think maybe the inventory a little bit old in this case. That's why the AOC is a little bit higher. So I think we need to check more with the other model for more detail about that. Okay, thank you. Attention. Đâu?
Yeah, good afternoon, everyone. Yeah, there's Professor Maria and everyone. I would like to introduce my comparison analytical hierarchy process, ASP, and frequent ratios, FR methods in assessment of landslide accessibility, a case study in Banyan districts in my province. So this is my outline. This is my outline divided into 4 parts. So first of all, this is some of the introduction about the landslide as we go a little quick. So the landslide is the phenomena of movement downslope of mass slope, this or soil, and have some kind of landslides like the fall or slide, flow, or topper. So and the develop of data science and we can forecast the landslide susceptibility, the level of the abilities to occur the landslide by using the map of the cost factor, using the GIS software or some model to build the landslide susceptibility. So the constitutive factor for the landslide, we can divide into the sum of group factor. That the first is the topographics, like the digital elevation model, slope, aspect, or the curvature. On the geological, we can have the geological map or the four network, or some of environmental factor. So for the model to assessment the landslide accessibility, we have the two group, that the qualitative model and the quantitative methods. When the qualitative methods based on the experts evaluation and inventory mapping, the quantitative methods based on the statistics methods or the mechanistics approach. So the two of approach have some of difference. So this study we focus on the to compare to represent a model of two methods, which show the ASP and the FR. So this the study area in Van Dien district. I think a lot of presenters have the introduced before. So, yeah. So about two of methods. First is the ASP. We use the space evaluation to compare to use the pairwise matrix based on the 9 level of compare the definition 9 this table. Yeah, you can see that. So after that, we use the equation of CR to evaluation the model. The CR can calculation by this equation, where the RI is a random consistent index and the CI is a consistent index that expressed as the equal CI below. Yeah, and the frequent ratios methods, the Professor Van Anh has the intros in the last presentation. So for the data to use for this two model, the first we use landslide inventory. The landslide inventory point we use from the national project in the 2000 in the 17, and have a some point we have go to the field trip and the collect in the 2022. So, and we divide to the 70 point to use to build the model, and the 30 point to testing. And we use totally 10 causing factor. The first group is a topographic. We can see that we have a slope, aspect, plan curve, and profile curve. So for the geological, we have the geological map and the full network. And some of factors of the environmental group, like TWI, road network buffer, river network buffer, and the land cover map. So and that's the result. The first is for ASP model. We can see that the pairwise comparison matrix. Based on this table, we can see the highest weight for roads, and the second one for the land cover. Yeah, and this weight. The weights be from the pairwise comparison matrix we use to calculation the landslide accessibility map. And for the frequent ratio, we can see the figure that's compare between the frequent ratio and the landslide rate. For the example, some of the factors class, we can see when for the slope, when the slope increase, we have the increase of the frequent ratio. Yeah. And this is the landslide accessibility map and the model evaluation. So we can see have some similar between two model. And the red and the yellow color is very high and high accessibility of landslide. We can see that the high areas is along the the road, the main roads of the Van Yên province. So have some roads in the Phong Dụ Thượng and Phong Dụ Hạ. Yeah. So and the compare between two model with the frequent ratio have slightly higher of the AOC value are the 0.77. For the conclusion, the study that's compared and evaluation the ASP and FR model in calculating the landslide accessibility in Van Yên district. So the study demonstrated that the ability landslide prediction of those two models, the IOC value of FR models is slightly higher when compared with the ASP model. The spatial distribution of high accessibility landslide show that the major of landslide prone area are located along the roads and where there are high slope. So I finished my presentation. Thank you so much.
Okay, I think Marias is busy with the other meeting and I think workshop. So thank you for listening in the first session from Vietnam side. So we have some like 5 or 10 minute break and yes, 5-minute break and we continue with Italian side. Thank you. Okay.
Học sinh sinh viên chị Thủy.
Giờ bạn xin phép
Cho các bạn. Dạ.
Cái này hai người nữa đúng không?
Lịch là 5 giờ.
5 giờ. Hả?
Cô Văn Anh nhanh nhé, cô vừa bảo vừa trình bày
Đâu
xong.
không phải, cô bị bảo vệ gọi xuống di chuyển xe.
Làm sao?
Thì bây giờ cô không ra, lát nữa ấy là không ra được.
À.
Dạ.
Em chẳng treo số điện thoại. Điện thoại chẳng treo ở đấy.
Xe à? Vâng. Thế thì khả năng là cũng ăn dính đòn rồi.
Không, em biết tí bên trong rồi.
Bên trong thì em mới không ra được, hiểu không?
Tại vì tí là dựng sân khấu đúng không?
Sân khấu rồi dạp, quên rồi chạy chiếc nó lên. Em dạng như kiểu thì vẫn có thể ra được nhưng mà ý là nó khó khăn thôi.
Dạ, gửi ở trường chị thì mấy hôm.
Được. Ông Vasil ở đâu?
Vasil ở chỗ hàng bún.
Eden à? Có Eden cùng với ông kia luôn à?
Cùng chỗ.
Ông kia tên gì?
Venka.
Venka. Rồi hôm qua đi đưa bà Kho đi.
Thế nào vậy?
Bà đi bà kiểu đau chân quá. Thế sao mà bảo chứ thua cả Việt Nam.
Tưởng bên đấy phải thích đi bộ chứ.
Đâu Thái mà.
Nhưng mà tưởng là
Thái nó đi, nó lên xe xuống một mình.
Yeah.
Vâng, đang nghỉ ấy ạ. Đợi tí chị ơi.
Nhưng mà em tưởng là hay vợ chồng là sống bên Nhật.
Ông bà này.
Vâng.
Không rõ là sống ở Nhật hay ở đâu nữa. À đâu? Ở Thái mà.
Ở Thái à?
Ở Thái. Bà bảo là bà ở bà cho xem cả nhà mà.
Vâng.
Bà bảo là tín mày sang tao để tao dẫn mày đi chơi mấy nơi.
Renzo, mi senti? Ok.
Faccio la prova anch'io, mi sentite?
Sì, no, perché è un giro di cuffie strano che abbiamo organizzato qui.
Ok, voi mi vedete bene?
Sì.
Ok. Monica, Vasil ti ha già dato l'autorizzazione a caricare?
Tutti abbiamo l'autorizzazione perché Zoom non è Webex.
Ah, ok. E allora io inizierei a caricarla.
Ok.
Okay. So now we
Deve-
start to the second section. So the first, I would like to invite Dr. Vasin. Yeah, no? Who is that? Okay. Thank you. So I move to I think it's the last presentation, study of the this posing factor to shallow landslide, checking for the definition of rainfall threshold and for landslide sensitivity mapping. I would like to invite group of professor and group of professor, Laura.
Okay, so thank you very much. Hello, everybody. Can you hear me?
Yes, very well. Thank you.
Okay, perfect. So I will present the progress of the work for the geological section. And the presentation is organized as follows. So I will start with a brief introduction, and then my colleagues, Lorenzo and Monica, will present the two main technical parts. The cooperation between our university, Politecnico di Milano, and Hanoi University was born from the need to study the impact of climate change on landslides. As you remember, during the last meetings, we focused on two particular case studies, Ruinon landslide and Val Tartano in general. But now our research aims to better understand the effect of climate change on the predisposing and especially on the triggering factors to shallow landslides. Okay, you can go on. Okay. The effects that scientists had long predicted are now occurring. And here in this slide, you can see several effects, such as drought, fire, and sea level increase, storm intensity, the problem of snow melting, and so on. In a changing world, we would like to better understand how these effects may change our approach in the study of landslide, and if the territory will be more prone to landslide events. And unfortunately, the answer is yes. We know that rainfall is the major trigger for landslide, and for rainfall thresholds is the most used instrument in landslide hazard assessment and also in early warning system. Even if good progresses have been made in linking the amount of rainfall needed to trigger failures, the nexus between climate change and landslide initiation appears more complicated because it is necessary to take into account several effects. And so further studies are necessary. How can we adapt our approach on climate change? How an increase in extreme rainfall events, for instance, in dry soil, may directly affect the frequency and the magnitude of landslides? We decided to consider two different conditions. You can change. Okay, thanks. The first one, presented by Lorenzo Panzeri, deals with the role of rainfall and also snow melt, so water in general, on landslide. In order to test a different scenario that takes into account future climate projection, we decided to perform several laboratory tests on a landslide simulator. We started to consider the state of the art with the current rainfall thresholds, and then we test different climatic conditions on the landslide simulator, with the purpose to better understand how climate change may change again the thresholds. All'altra. Okay, thanks. The second part of our work, presented by Monica Corti, deals with the fire effect, another important effect of climate change. The rising temperature due to global warming, the longer summer dry season, the reduced snowpack are only several effects that show how climate change is a key driver for wildfire. Wildfires make the landscape more susceptible to landslides. But the question is, how landslide can form post-wildfire? Is it necessary to modify rainfall thresholds post-fire or not? This is yet a challenge, but the increase in fires requires to study also this problem. This information will be, of course, important for effective rainfall threshold definitions, but this information can be also used for susceptibility map. But now let's start with Lorenzo for the first technical part that deals with landslide simulations in our laboratory. Thanks, Lorenzo.
Okay. Good morning, everybody. I will start speaking about. Okay, so. Sorry. I will start speaking about shallow landslide, and the goal is the definition of triggering threshold for the point of view of the rainfall event. And our interest is mainly in the evaluation of the processes happening inside the landslide body. As you can see from the images, we have different behaviors starting from the initial saturation of the lowest part of the landslide body, then till the complete saturation of all the body. And everything has the goal to define and understand the stabilizing and destabilizing forcing acting on this event. As Professor previously explained, I want just to describe how our landslide simulator in the laboratory GAP2 in Lecco site at Politecnico is equipped. We have flume that is long more or less 2 meters with a width of 0.8 meters. And this flume is equipped with different tools and devices that allow us to interpret the results coming from this simulation. We have sprinklers that provide the rainfall event and provide water to the landslide body. We can decide the amounts of water per minute, per hour. So the intensity of the event. Then we have other devices, like for example, the TDR, time reflectometer, which is able to describe the volumetric water content inside, in a certain point inside the landslide body along all the experiment. We have also pressure transmitters able to provide us information about the pressure inside the pore, inside the landslide body. We have equipped this instrument with porous head in order to have just information linked to the movements and the process link to the pressure related to the water presence. But moreover, we have also other tools from other subject, other approach. For example, the geodesistimeter, which is a geophysical tools, which is able to provide also information about the behavior of water inside the soil. We have also other different instruments that we have used in laboratory. They will not be present in this presentation, but we will also use a fiber optic and a soil moisture sensor. Moreover, we are going also to consider other different approach. For example, the photogrammetrical one. We are going to use, we have used GoPro camera, laser scanner, and also data station in order to evaluate the displacement, the velocity of movement of our landslide body. And we have also used, for example, to analyze the lowering of the snow mantle in some cases when we have considered the presence of snow over the terrain. The experiment I'm showing now in a video, the experiment, and we will define a slope, we will define a material, define intensity for the rainfall event, and then we will understand and look at the type of collapse, the formation of the cracks, also exploiting the photogrammetrical images. And then we analyze from the data obtained from the different devices, the behavior of water inside the soil in order to understand in a better way the mechanism of collapse. As I explained to you before, we link the information coming from different approaches. So we have on the left, the images coming from the geophysical tools, from the electrics, and we have information about the resistivity. So when we have the part colored in red, we have, for example, the presence of void. So we can see in advance the formation of cracks inside the soil, cracks that have been noticed and seen from the photogrammetry. At the same time, also the sensor inside the landslide body provide us information about the increasing, for example, of volumetric water content during the rainfall event, or the activation of the pressure sensor when water is close to them. So different location for the different sensor and different activation for this sensor. We have at this point, in order to understand also the behavior, the behavior of the landslide will depend on several parameters. We have done some analysis changing, for example, some of them. We have changed in this case, in this experiment too, the volumetric water content at the beginning of the experiment. And we have kept all the other parameters fixed in order to understand how these influence the mechanism and the time of collapse. We have seen that the big difference is in the time of collapse. We have collapse that happened after around 35 minutes in the second experiment, while we have a collapse after 22 minutes in the first one. The behavior is almost the same as is shown by the different sensor. We started with negative pressure, which is higher for the second case because the terrain is drier. So we have less amount of water inside. We have developed several cases, and this experiment is just one of them. And we want to describe the provision of water, the supply of water from upstream, simulating water coming from, for example, snow melting events or events that allow water filtrates from above. So we don't have no more the rainfall event, but we have the same amount of water provided in experiment 1 and 2 from this artificial drone located in the upper part. The results can be seen in the video and are described by the sketch on the left, where we start to see a lot of runoff coming from the lower part of our body, from the tube. Then we have no clearly formation of cracks, but a movement that is involving all the landslide body. This movement is faster with respect to the previous cases. So we have a completely different mechanism of failure. Again, looking at the different tools that we have considered during our research, we can exploit the potential of geophysics, and it's clearly visible starting from the upper part of the images of the slides. The moving of the waterfront that is starting from upstream and involves all the landslide body. The part color in blue means that we have high conductivity, so the presence of a conductive material, which is water inside the soil. So we have a complete saturation in the end, with part colored in green, which represents the formation of the crack more or less, even though the crack
Lorenzo? No, we lost you.
Yes, I'm not with them. I try to call them. So one moment, please.
for the mechanism that we have used for the evaluation of the collapse mechanism. And we have
Lorenzo.
Okay, we have also tried
Lorenzo, scusa. Sorry, I speak in Italian, maybe it's better.
Okay.
Ti abbiamo perso per un secondo, non sentivamo più niente e adesso io non vedo la presentazione. Dovete forse ricaricarla, non so se... Basil, can you see the presentation?
We don't see the presentation.
Ok, so now I upload.
Ok, we don't have internet no more.
È saltato internet. Sì.
Just a matter of internet. Okay.
Sorry, we had a problem with connection.
Okay. Just I'm concluding, and I'm just showing to you different. Okay, sorry. Okay. Concluding, I'm showing just you the different experiments that we have performed in laboratory in order to evaluate also future developments are linked to the evaluation of the presence of snow or snow mantle over the terrain in order to understand also the effects of water filtrating through the snow melting.
Okay, so now very quickly we want to show you also our results related to the second part that Laura anticipated at the beginning of our presentation, that is the influence of wildfires on the slope instability. Because wildfire is a problem that will increase in occurrence due to climate change. So it will be more urgent to deal with the consequences of wildfires. And many authors in literature found that the vegetation removal and the soil burning also change the hydrological condition of slopes. And this, as shown in this picture, influences the formation of new debris flows. So after wildfires, it's common to observe a higher runoff, higher erosion, and a higher debris flow hazard. Also, this problem is very common in the Alps, so in our region. So we decided to study this problematic in an Italian location to define also new rainfall thresholds for instabilities. Our monitoring activity was started in October 2019, and it's continuing now. The monitoring was divided on 3 different sites in the same area. During our first survey, we identify burnt woods, burnt grassland, and also we studied also a nearby woods that wasn't burned for comparison. We computed different indexes using remote sensing, and we studied their evolution over time in order to derive also a recovery trend for the area. Also, we decided to collect some soil samples to evaluate the hydraulic conductivity and to perform rainfall simulation on our landslide simulator. And also we performed some field monitoring related to the infiltration of water. So we performed some falling head infiltration tests distributed over time in these 3 years. Here, very quickly, I will show you some results. With respect to the remote sensing part, we identified a clear difference among the 3 areas. So you can see that the burnt index in the unburned area is constant over time, but this is changing in the burnt area. And from this, we can derive a recovery trend. That for our area is around 7 years after the wildfire. Also, from a remote sensing, we can derive a recovery of the evapotranspiration coefficient, because after the removal of vegetation, we know that evapotranspiration decreases. And this recovery was found from this equation. From the field monitoring, we observe that without a complete restored vegetation coverage, we have a more direct response to precipitations. So in the burnt woods, and particularly in the burnt grassland, after rainfall events, we have a quicker answer to rainfalls. That means that we have a higher saturation in the terrain. At the end, we performed rainfall simulations using the simulator that Lorenzo presented you. We considered also a runoff collector in order to derive the infiltration over time in our simulations. And we observe that, first of all, if we perform rainfall simulations on burnt soil, we can have a landslide, also considering a low slope. On the contrary, if we perform these rainfall simulations on burnt soil, we observe a higher runoff and no crack formation. We performed many simulations on the same soils, and we observed that after some simulations, so after times of washing this soil, we observed that the behavior of the 2 soils is becoming more and more similar to each other. That means that the characteristic of water repellency that is present in the unburned soil that prevents to a quick saturation of the rains after rainfall can be decreased after subsequent rainfalls without a vegetation coverage. So this can be also a problem that we can observe in after deforestation. So if we remove the vegetation in a slope, we will have an increase of instabilities because of the lack of soil water repellency after some times, and for a quicker response to precipitation. Our study is now merging all these results in order to derive a geohydrological model of burnt soil that will help to estimate the saturation level of terrains and to define rainfall thresholds for instability triggering. So the final remark is this. In the next presentation, our colleagues from the geomatic groups will present you the new results regarding landslide susceptibility mapping. These processes start every time from the terrain variables as shown in the algorithm of the paper of my colleagues. We studied these terrain variables and how they changed, they are changing with climate change. And this can be a starting point to evaluate also new rainfall thresholds at regional scale for example, our region or other regions in the world. Thank you very much.
Thank you. Thank you very much for your presentation. So very interesting and very good work, because we always need the geological science to deeper understand how, when landslide study. So we can move and discuss. With the titles landslide monitoring and susceptibility mapping. Thank you.
Thank you, Kuang. I just more or less I'm going to show the results from our project from this year, and as you already said, I'm going to show some about our advances in susceptibility mapping and landslide monitoring. But firstly, I wanted to do a quick recap on the other products that, for example, the application, the mobile application, that it's already in Vietnamese. And 2 days ago, actually, we did let's say a launch organized by the scientific attaché of Italy in Vietnam, Professor Marco Abbiati. And now the app is working. We have the database, so we have to push the citizens to collect data. Hopefully, as Kwang said the other day, more than 90% of the people are interested of the locals to contribute. So hopefully we'll have a lot of information soon. The other part is with the GeoNote, that it's available and data can be uploaded there. We already did upload our data for Valtartano and Valtellina. And then the WebGIS that it's linked to the GeoNote just to browse the data. It's also working. You have the links. Okay, so I'll continue with the susceptibility mapping. Starting that, as we heard already before, we were working on Valtartano, the relatively smaller basin, but then we went to Upper Valtellina, and from recently also we started working on a third basin in Valchiavenna, that it's more or less the biggest one from the three. And even though the landslide count is not that high compared to the other ones, but still we employed with a student of ours, we employed the non-landslide zonation approach, so we can verify, and again we have very good results, a bit yeah, around 3%, a bit more than 3% compared with the landslide inventory. Okay, this is again about the non-landslide zonation, the comparison that we did. So yes, this is for our third case, Valchiavenna, the non-landslide zonation. And you can see that actually those in the north part, the two big areas are actually two lakes, and then in the south area there is one big flat area. So still our approach, even though that it's not that perfect as the previous area, still it's showing really good results. Then, as we already had models, susceptibility models using random forest built for Val Tartano and Upper Valtellina, we combined them, our student, and she applied it directly on the Valkia-Vana region to see how is the generalization of the model. So actually the results are not that perfect, but we're very happy with them, just without tuning, directly applying the model. And okay, after that, with applying including also training data sets, training points from the same area, we rerun the model. The evaluation metrics are increased. However, you can see that the whole map kind of like got in red, but since this is still work in progress, we have to re-evaluate and tune again kind of the initial results for this area. Actually, still ongoing with the same project part, because we want also to apply the whole approach for the whole region of Lombardy. So, for example, this is the whole landslide inventory in Lombardy. You can see that everything is located in the north parts, in the mountainous areas. And the initial result is again the no landslide zonation that was applied for the whole region. And compared with the landslide inventory, we have results of error of a bit more than 2%. Okay, so the next steps are actually applying the more bit complicated approaches, the ensemble learning, that these are very preliminary maps for Upper Valtellina, and when combined, when the ensemble is applied, the results are good, even though that there is no tuning on these models. They're really, let's say, by default settings. So yeah, here just some reports of the improvement of the results. Then the next step of the work would be to define a better threshold criteria for the probability and for defining the classes, not just putting 0.5, for example. Yeah, there is we have another student that she started her thesis with us. I don't have slides, but she's really in the beginning of the, let's say, literature review of the state of the art, but she will be working on the applying deep learning and CNNs for landslide mapping. So probably later you can have discussions also, since I saw you were working with landslide for sense. You can explain us more on that. Okay, on the monitoring part, just a recall from kind of last year's results. Lorenzo, he was doing his thesis with us, already graduated. He applied a maximum cross correlation approach for Sentinel and PlanetScope data for monitoring the displacement of the Ruinon landslide. So let's say kind of first step, we continued. Okay, so yeah, we are doing on a manual for producing an for using UAV and free and open source tools. Okay, probably I mixed a bit the mixed the order of the slides, but anyway, so we are doing the monitoring of the Ruinon landslide. So since the start of the project, since 21, we did 2 surveys. This year in 2020 we did another 4 surveys. So in total we have 6 with different products: UAV, point clouds, DEMs, and everything was kind of normalized in 10 centimeters per pixel as a minimum. In general, however, we have more than 10 surveys for the same area, because also the local environmental agency gave to us. And so in the end, now we have really like high resolution time series data. So of course, we had to implement something for monitoring the local displacements. Just to mention that all of the orthophotos are already available in the open area map, so can be found there. Just ours, not from ARPA. So to apply better monitoring some displacement approach, there should have been some kind of normalization of the products, because if you see the point clouds and in the orthophotos, there is quite a big difference between the products in terms of shadows, sunlight, vegetation state, since they're in different periods of the time. So we had to apply some approach to normalize, let's say, the products. And for that, we came with the approach for the red relief image map. So for example, if we just this figurative just to show the whole process, that for example, if we start with the area of Bormio and Ruinol landslides, we can compute from the DEM, the positive and negative openness. We can differentiate it, and actually we will get a much better visualization compared to a simple one-directional hue shade. And when this differential openness is combined with the slope, we can obtain this red relief image map, which is even just for human eye, it's really easy to perceive the depth and the elevation of the topography. So when we apply an approach that, for example, is computer vision approach based on the intensity, so everything is normalized and there is not going to be any, should not be any problem for computing displacement vectors. Just I wanted to give here a bit zoomed examples. On one side, on the left, is from a survey from July 21. On the second, on the right, is May 22. You can see that firstly, the light conditions are different. So in one on the left, there are really strong shadows, and the vegetation is much more green. On the other side, everything, the light is much more flat. So it's a bit hard to distinguish what is what. When we apply a hue shade, for example, again, it's not really easy to differentiate the single elements. And at this resolution, it's some of the boulders have are bigger than 5 to 10 meters. So we can also capture smaller boulders from that. And when applied red relief image map, everything is much more clear. You can see even some channeling that is formed through precipitation. So yeah, this is just some examples of some of the maps. Everything is much more standardized, let's say. And on that, we applied optical dense flow for estimation of the displacements. The first results are the one provided from the environmental agency that actually they did the surveys during the most active period of the landslide. So that's why everything is quite moving. It's really, it is interesting that there are some spots that it's lost the correlation. So that's why there is a hole in the middle of some of the areas. But last year, let's say the landslide is much more calmer. There is one specific spot that was activated also during our surveys. Rather than that, actually most of the displacements are related to some small boulders or due to the vegetation again. Difference because when reconstructing from the photogrammetric manner, there is also always a bit harder to reconstruct this part. So that's why there is a difference there in the bushes or in the trees. Okay, so basically this was for the whole approach, and I just wanted here to show the publications that we did together for the year, where yeah, the first two are still on review, and the rest are already published. And thank you from my side.
Thank you, Marcio, for your very important and interested work up to date. So we need to learn something from you for make our susceptibility map is more rich and more comparison between all the method together. So we, as usual, we move to the discussion session. So I would like. Yes, I know. Yes, so last presentation, I would like to invite Dr. Teresa Bortolotti. The title of presentation is a special point set approach for modeling landslide susceptibility. First, results in Van Tano. Thank you.
Good morning, everyone. I just realized that I didn't allow my Zoom to share my desktop, so I'm just setting the things up. Sorry. I don't know what's going wrong. Okay. Just 1 second. Okay, can you see my screen now?
Yes, yes.
Okay, great. And now can you see it full screen?
Yes, yes. Thank you.
Okay, great. Thank you. Okay, good morning, everyone. I'm Teresa Bortolotti. I'm going to talk to you about the spatial point process approach for modeling landslide susceptibility and showing you some first results in Valtarno. This is a project that was born from a newly born collaboration from the Department of Mathematics and the Department of Environmental and Civil Engineering in Politecnico di Milano. Alessandra Menafoglio and Simone Vantini are associate professors in statistics at the Department of Mathematics and particularly at MOX, which is a laboratory of mathematics there in the department. The collaboration started between Professor Menafoglio, Professor Vantini, and Professor Biaggi. I myself am a first-year PhD student in mathematical engineering, and Giulia Patané, she's a master's student in mathematical engineering as well. Okay, I wanted to do a little disclaimer on this presentation. I would like to see what I am presenting to you today as the definition of a line of research rather than a completed product of research. So what I'm showing you is rather a novel approach toward landslide susceptibility modeling rather than a definite presentation of a novel model for it. Okay, what is our problem? We are in Valtartano. As Basil said, it is a mountain area in northern Lombardy. This is Lake Como, and the green area is Valtartano. This has been highly subject to shallow landslides and debris flow. Thanks to Basil and the Department of Civil and Environmental Engineering, we have been provided with high resolution geophysical information on the area and with the historical landslide inventory of the landslide occurred in the area. What we want to do is to take advantage of the great availability of information and to build a model, to build a tool that is able to model landslide susceptibility and that is highly interpretable and generalizable. Generalizable meaning that we can take the model and export it to novel unregistered area and see how landslide susceptibility behaves there. About the methodology, we propose to use and to model the intensity function of a spatial Poisson point process. I'm trying to give you an overview about spatial Poisson point processes. So let's W in R2, which is a space, the area of our interest, so Valtartano in our case. A spatial Poisson point process is a random pattern of points in W, in the area. By assuming that the process is Poisson, in particular, we are assuming that there is no interaction between the points of the phenomenon that we are observing in the area. In some useful statistics are used to describe spatial point patterns. And these are first intensity measure, nu, which to each subset B of the area of interest associates the expected number of observations occurring in B. After you define the intensity measure and under the assumption that everything works well and is regular, so the process is regular and the area that you observe is regular, mathematically speaking, you can define the derivative of this measure nu as the intensity function rho, such that the integral of B of rho du in the U equals the expected number of observations occurring in B. In our case, the observation are the occurrence of landslides. We say that the process is homogeneous if the intensity function is constant over space, and we say that is inhomogeneous otherwise. Why are we talking about intensity function while we want to model landslide susceptibility? Well, what I am trying to convince you about is that intensity function and landslide susceptibility are strongly connected. In our case study, intensity function is the density of the number of landslides per square kilometer. It is possible to show that in a small enough portion of space, this density of landslides corresponds to susceptibility. So when we want to model landslide susceptibility and the intensity function on some effects of space, be it linear or nonlinear, those effects impact the intensity function in the same way as they impact landslide susceptibility. So in terms of interpretability and generalizability, nothing changes. Okay, then clarify this, the goal is to model the behavior of rho, so the intensity function on the domain of analysis as linear or nonlinear function of some explanatory variables. And then I'll tell you a little more about them and about the possible choice of these explanatory variables. So let Z the vector of explanatory variables considered. Then we model the log intensity as a function. Again, it can be linear or nonlinear of this vector of explanatory variables. We model the log intensity because it allows us to guarantee positivity of the estimates. Okay, I told you that we are given with high resolution data and with a lot of information about Val Tartano. In particular, we have given with the landslide inventory on that registered the occurrence of 686 landslides in the past. And we are given with 5-meter resolution raster data of geophysical covariates, some continuous, some categorical. Among the continuous, we enumerate the digital terrain model, the slope, northness and eastness, the topographic wetness index, and the normalized difference vegetation index. And among the categorical are river, roads, and faults buffers, and land use and land cover. When we decided to use Poisson processes to model the occurrence of landslides and the intensity of the occurrence of landslides, we need to deal with points in space rather than with diffused information. So what we have to do is to transform the information that the polygon of the area of an occurred landslide bring into a representative point. In particular, we decide to identify this representative point as the centroid of the polygon of a landslide. And we associate to this point a vector of covariates that are evaluated as a weighted average of the covariates of the pixels that lie within a distance of 50 meters from the centroid. This weighted average technique is a classical statistical technique that goes by the name of kernel smoothing. It basically allows us to borrow information from nearby pixel to create a robust statistics and a robust information on the centroid of the landslide. Okay, I told you about our goal, I told you about our data. Now I want to tell you about how the road that we follow to build a model for landslide, for the intensity measure. We started from the easiest one, the simplest one, and we complicated it step by step. So the simplest one models the intensity function as a constant. Then we try to model the intensity function as dependent on the coordinates, so on longitude and latitude of space. And when we decided to add, and you'll see why, to this nonlinear dependence on coordinates, also a linear dependence on the geophysical covariates we are provided with. This obviously goes in the direction of building a model that is interpretable rather than also powerful in predictions. These are first results, visual results that I show you here of the intensity that we estimate. On the left panel, you see the homogeneous result. So it's all green, it's all constant, all over space, while including a nonlinear dependence on longitude and latitude allows the model to light up a little the areas which are more densely populated by centroids. And then with the additional inclusion of a dependence on covariates, we see how a spine lights up in the area and is able to better capture the presence of high density area of areas of high density of centroids. Okay, this is only a visual inspection, but how can we really assess the goodness of these models? How can we really compare them? Well, what we use are diagnostic tools made for the case. These are diagnostic that work on the residual of these models. What are the residuals? We define the residuals as the difference, the residuals in a certain area B as the difference of the number of points observed in B minus the expected value in that area that our model estimates. So what we want to observe in a model that works well is a smoothed residual field, the plot on the left, that does not present some strange patterns in the areas and not high value of residuals. Then in the middle, the Larkin variable plot should display a black line that remains more or less along the horizontal black line and within the gray area, as it displays the presence of any residual dependence that we haven't captured on the covariates. So we would like a model that is able to capture all the dependence that intensity has on covariates, on the included explanatory variables in the model. Eventually, the cuckoo plot is the panel on the right, and it checks if the distribution of the residuals is compatible with the assumption of no interaction between observed landslides. What we would like to see here is that the points remain within the red buffers along the diagonal line. We don't want to observe a deviation from this behavior. Okay, so now I'll show you the diagnostic for all three models that I briefly enumerated before. First is the homogeneous one. You see in the bottom left panel the result, the constant result. In the bottom right panel, you see how there are actually patterns in the residuals, which is something that we wouldn't like to see. Also, in the two bottom left panels, you see the Larkin variable plots of the residuals on longitude and latitude. These have not been introduced in the model, and as you can see, there is a clear dependence of the residuals on these variables. So it is a clear indication that these variables should be indeed included in the model. Also, the cuckoo plot is not satisfactory at all. These are the diagnostic for the model that includes only the coordinates, in a nonlinear dependence on the coordinates. As you can see from the Larkin variable plots in the bottom, the dependence on the coordinates is well captured from the model, so the coordinates should be in some way included in the model. And also the smoothed residual field in the top right panel is very good for us, and the QQ plot too. So this is a good model, not really interpretable, as it depends on coordinates rather than on covariates. By plotting the Larkin variable plots of this residual, of this model on the covariates that we didn't include in the model, we see that there is still some dependence that we aren't considering. So this is a clear suggestion that we should include these covariates in the model. And actually what we do in the next model is that we include these covariates. So the diagnostic for remains practically the same, but now we see a little improvement in the Larkin variable plots, since, for example, in the DTM, in the bottom left, you see that the dependence is quite captured from the model with a linear introduction of a linear dependence of intensity on the DTM. But the others are not so good. There is some dependence left that we are not capturing. So what is the idea now? Well, the idea is to include the covariates in the model with a nonlinear dependence. And hopefully, this will allow also to avoid the inclusion of the coordinates, so of longitude and latitude, which reduce the interpretability of our model. Okay, so these are the remarks that we can do after all these diagnostics that we performed. First, that the spatial coordinates alone do not adequately capture how intensity varies over space, apart from the fact that they are not really able to produce a tool that is interpretable, and that nonlinearity in the geophysical covariates should be included in the model. So the next step is to include a nonlinear dependence of the log intensity on the geophysical covariates. We do it with a GAM, which is a generalized additive model. It is a statistical tool, quite used in the literature. And I'll show you the diagnostic of this model. As you can see, we haven't included longitude and latitude, but the Larkin variable plots are actually quite good. So the inclusion of nonlinear dependence only in the covariates is quite able to capture how the intensity behaves in space. And if I now show you the Larkin plots on the covariates, these are actually good. We are capturing the dependence of the log intensity on the covariates. So this is quite the answer we are looking for, or at least this is the direction which we have to go towards. Okay, I showed you many different models. Typically, what one should do should be validation, meaning that you need to, and by validation, I mean being able to assess the ability of a model to generalize to unseen areas. One typical method to do that, methodology, is the leave one out cross-validation, or a k-fold cross-validation. In the spatial context, as it is ours, you cannot really go for a leave one out cross-validation because nearby points are strongly correlated. And by taking out random points, you are not really taking out information. The information on that point, on those points, remain inside the dataset. So an alternative to this approach that we are considering, and is still a work in progress, is a spatial leave one out, that instead of taking out random points from the area, takes out random clouds from the area, so that you create holes in your domain of analysis. You train the model in the remaining area and you test in the hole that you took out. These are first results of validation that I'm showing to you. These are not perfect because they rely on a method, on a validation method that introduce some additional error and noise. So these are not perfect. I'm not going into deep explanation of why they're not perfect, but still they are suggesting us that the model in the center, which is called COF-GAM, which is the model that includes nonlinearity only in the geophysical covariates, is the one that is the most generalizable, the one that when exported to an unseen area performs best. Summing up, the intensity of the process seemed to be well captured by nonlinear effects, and by modeling intensity on the geophysical covariates, we gain in generalizability. Of course, we made some modelistic choices, like for example, the one of summarizing the information of the entire area of a landslide in the centroid. We may do some sensitivity analysis to see what changes by moving the position of the representative point of the landslide. And of course, for the developments will be the visualization and interpretation of nonlinear effects in order to really take advantage of this interpretable tool that we are trying to model. Then go on with the validation via both spatial leave-one-out, which is the technique that I just mentioned to you, and on unseen data, like for example, on the dataset of Upper Valtellina. Then another approach, then what we would like to do is a validation with the state-of-the-art model for landslide susceptibility. So maybe test what we are offering as a model against random forests and other methodologies that also you presented today, and eventually perform uncertainty estimation of the predictors, because whenever you estimate something, you also want to assess what is the uncertainty linked to that estimate. Okay, I'll leave you here some references on point processes, and of course, the link to the GeoNode, which is our source of data, together with Basil. So thank you.
Thank you for your presentation. This is a different point of view to build up the landslide point around space. So, okay, this is a time for question and discussion. So I will, because it's today is from my side, people is not so. Today is quite a busy days in Hanoi and in all Vietnam. So is less people attend personally. So maybe from some question from online part.
Hello, I'm here again. So after the discussion about CADEO, now I have some action also to do with respect to the Erasmus project. No, but I want to thank all of you, first of all interesting presentations and activities done in the frame of the project. With respect to this last presentation, I believe that, sorry, I missed something in between because I was on the other side. But with respect to this last, I believe because we have already solutions, so susceptibility maps done using random forest and other methodologies. So for sure, we can compare the results that is obtained in this case with the results that we obtained using other methodologies. So in the end, we used random forest because it was the best one, giving the best results. And so we can compare these methods to see how differently they behave. For sure, I believe that it is interesting, and so we will be in contact with Teresa for checking this solution. I didn't see your susceptibility map for the Valtartano, but I believe that you computed a susceptibility map as a final part of your result, correct?
Actually, we rescaled our intensity maps as they correspond to a susceptibility map.
Okay. So we have to understand if your intensity map is exactly the corresponding to the susceptibility map that we computed, and if not, what we have to do to make them similar, if they are giving the same piece of information or not. But I believe in the end, in our case, it's a probability map. And
Yeah,
so,
in our case too.
yeah, so at this point, if they are probability and they are immediately comparable. So this is something that we can do very quickly when Basil is back. Okay, thank you. And with respect to all the other presentations, please send to Basil in such a way to collect all the contributions, and then I believe that we need to have a look and to go ahead considering all the contributions by the different teams, trying to homogenize everything and put everything together. This is all on my side. I don't know if you have other comments. I see that Dean is again here with us.
Yes, I still
Fantastic.
follow the presentation. I just missed presentation from Professor Chen Văn.
Okay. Okay. Sorry, I didn't realize you were here. Okay. No, but good. I believe that now on the Italian side, we are in the situation of starting thinking about the next year, because on our side, the project will go ahead also next year, and therefore we have to decide which is the direction of the research, taking into account also the suggestions on the Vietnamese side. So I want also to discuss with Quang, first of all, but also Vanan and also Dean, the other colleagues, to better understand which can be the most important directions on both sides. And so I believe that before the end of the year, we will have a small meeting with few people. It's not necessary to involve all the people here. Can be just a few people for discussing about how to go ahead for the next year. And for sure, next year, Basil will be with us. Basil, yes. And you know that Basil now is he has finished his PhD. So he's entering in a new stage, because now he's no more PhD student, but he will stay with us working on this project, hopefully. I believe, I hope at least, because Basil is really the pillar of this project. Okay, so thank you so much. And if there are no other comments, I will say hi to all of you. And again, I will contact the Quang and Dean and Vanan for discussing about the next year.
Okay. Okay. Thank you, Maria. So yes, okay, we can invite some expert on this field to think about the next year proposal. Yeah. And today is many people cannot attend, so I think they are very interested to have your slide from both sides, even slide from in last 14th also interested to jump, so they want to follow us, because I think our project is like a volunteer in this field, because we do everything from beginning from zero to like the end. It can send information to the end user, from data collecting and processing, image, etc., running model, and give the data to give the information to all the end user. I think it's a complete system. Yeah, it's very interesting for everyone. So yeah, thank you. Maybe we can have a next discussion with a group of experts again. Yes, thank you. Dr. Định, Vân Anh, maybe Vân Anh sees no place to park a car, so she should move somewhere. I don't know. Where is she now? Because my university, they build something on the open ground to make the festival, music festival or something like that for teacher days. Yeah. Anh Định ơi, có gì không?
Okay,
Invite
so
Dr.
yes, just to want to say thank you very much for all the effort from both sides, from Vietnamese and from especially from Italian side. I think that so far the implementation of the project going very well. I think that both sides, Professor Maria and Quang, coordinate from both sides very, very well. And I think that to the moment we promise, we can deliver what we promised, especially in terms of publication. We already published several publications in national and international journal. And our project also in spotlight. So within project, we can include another partner from another institution. And I think that one of the most prominent part is that we managed to propose Erasmus Plus project that is also lay the basis for us for further collaboration, both in terms of higher education, capacity building, and also to solve the real problem of Vietnam. And I think that the technology and the expertise from Italian in landslide management and landslide monitoring is very valuable for us. And we hope that through the project we have a master student, and maybe next project we have a PhD student to follow up and to build the capacity within HUNRE and also in my institutes. Yes, and we think that plans for next year. So Dr. Quang already discussed with me the initial plan for next year. So I think that from Vietnamese side, we commit to spend our best in both in human resource and also in the financial support from our department to the project. So thank you very much.
Thank you, thank you, thank you. And yes, I have a very last point. I want to recall to you, because not you specifically, you as Vietnam, because if you remember, Professor Abbiati last day told us about this possibility related to PhD students. And the main point, he said that the starting point is the agreement between the universities. So with respect to HURE, it has to be verified. Quang, I want you to ask to verify if the agreement which is in place is working for that case of the PhD, because there is an already existing agreement. In my opinion, is still valid, because if I'm not wrong, it was signed last year. And I'm also part of this agreement. And the point is to check if this is enough or if we need to do something more. Because as Professor Abbiati said, the deadline is next spring, probably March or something like that, which is not tomorrow, but as a matter of fact, is the day after tomorrow, because it's very close. If specifically, if there are other addendum of agreement and something to do. So please check on your side, because the main part is on your side, if the agreement is fine, and if it is not, specifically what we need to do for going ahead with these project related to PhD students. And I don't know if the same is possible also for Fenica University, because I know, Dean, that now you are going to the Fenica University.
Yeah.
And yes, I don't know if Fenica is interested as well in having an agreement, if there are. So please check also the situation there in
Yes.
such a way to be prepared, because again, March is far, but not so far in the
Okay.
end. So it's better not to wait. Yeah.
Yes. In terms of signing MOU, I will report to the Fenica director board, director and vice director, and I'm not 100%, but 90% sure that they want to sign MOU with you. With
Yeah, but it's
yeah.
a very long procedure. It took,
Yes.
I remember this one with Ure took so long time. So
Yes.
yeah, we have to start a procedure.
Yes.
We can know when we start, but not when we end. That is the
Yeah. Okay.
point.
Yes. There are several ways. For example, we can start from the department to department MOU.
Yeah, but I don't know. Yes, but the main point is that we need to do something that is useful for this application to the PhD.
Okay. Okay, I understand.
So our aim is to give the possibility then to Vietnamese students, because when these so the point is that there will be this grant from your side for coming to Italy and doing the PhD. So it's a good opportunity for students, but Professor Abbiati, so you have to search first of all how it is possible, if there is something explaining which are the steps, because it is not something that we have on Italian side, it's something that is organized on the Vietnamese side.
Okay.
So in case you can speak before with Professor Abbiati for better understanding what is already decided, and what are the documents that are needed to the university and everything, in such a way to be prepared by March. So before March, having almost everything in such a way that then you can apply.
I understand. Yeah.
I agree. Maybe we need to extend. I mean, before we have MOU with for our project, I think at that time is a little bit few months is not full in my side. For instance, I stop. I will complete in July next year, but MOUs is finished at May or something. We have some month lost, so we can do again. It's make the new times. when you
Yeah, but check please, which is the situation, because I believe that the main interest is from the Vietnamese side now, because there is this possibility of grants. And therefore, my suggestion is to check, obviously. Okay. So thank you. I don't know if Professor Biagi wants to say something.
No. Thank you for all these presentations. They were very interesting. And I'm quite happy to cooperate with mathematician in such new approach that we are working on. So thank you to everyone.
Thank you. Okay, so at this point, see you next year. With all the people. With some people, no, see you very soon. Okay, thank you.
Bye.
And
Thank
have a
you.
good
Bye.
evening
Goodbye.
or